Alright guys, we're now looking at our 5A.3 Math Learning Objective. I can calculate the probability of compound events by determining whether they are independent or dependent. So I mentioned this in the last video, right? In 5A.2 we looked at independent events and we just multiplied them together. Now we're going to decide if the event is independent or dependent. So it is a dependent event. A dependent event affects the other event. The biggest thing here is the total. What it means by affecting the other event is the total changes. Sorry guys, this pen's bad. I don't know where my pens were. Okay. So the total changes. And we'll kind of see what that means in a second. But we still have our keywords. We're always still going to see that word and. And is still going to tell us to multiply. Okay? So that part's the same for both independent and dependent. However, our other key words are without replacement, doesn't put back, keeps, anything like that, right? If I'm keeping it, I'm not putting it back, I'm not replacing it, right? Anything like that, then it's going to be dependent. So let's look at some examples. The first thing we're doing is just determining if the events are independent or dependent. You flip a coin and then roll a fair six-sided die. The coin lands heads up and the die shows a 1. So when I flip a coin, I have 2 choices, and then I roll the die and I have 6 choices. Okay? My flipping of a coin doesn't change how many choices the die has. Okay? So this is 2 completely separate events. And so therefore it is independent. Basically a lack of a keyword if it just says and, okay, then it will be independent. Alright, if I look at number 2, a bag contains 8 red marbles and 4 blue marbles. You randomly pick a marble and then pick a second marble without returning the marbles to the bag. The first marble is red and the second marble is blue. So again, I have marbles in a bag. I'm picking a marble, and then before I return it, I'm picking a second marble. If you think, first, I have 8 plus 4, I have 12 marbles in the bag. I choose one, and I don't put it back. When I go to choose the next one, there's now only 11 marbles in the bag. Hold on, it's loud. Okay. So the total number of marbles in the bag has changed because 1 is in my hand. Alright, and that's where this without returning. Okay, I don't put it back, and therefore it's dependent. Looking at number 3. A box of chocolates contains 5 milk chocolates, 5 dark chocolates, and 5 white chocolates. You randomly select and eat 3 chocolates. Okay? It's milk, and then dark, and then white. Okay? So when I first go to choose my box, look at my box, right? I have 5 5, and 5. I have a total of 15 chocolates. I choose one. If I eat my first chocolate, right, when I eat that chocolate, I now only have 14 chocolates. When I eat my next chocolate, I now only have 13 chocolates that I'm choosing from. Okay? So, and then I eat that one. Right? So again, if I'm eating them, I'm not putting them back. So sometimes you have to think about, is this a putting it back or not putting it back situation? Sorry, guys. So I'm not putting it back, and so therefore it is dependent. A cooler contains 10 bottles of sports drink. 4 lemon lime flavored, 3 orange flavored, and 3 fruit punch flavored. You randomly grab a bottle, return it to a cooler, and then grab a different bottle. The first time you get a lemon lime, and the second time you get a fruit punch. Right, so this would be like, I really want a fruit punch, I randomly reach in, oh, that's a lemon lime, grab the ice, oh, here's the fruit punch that I wanted, right? And since I put it back, right, this is independent. So basically, independent is you're returning it. It's resetting to like the original thing. Dependent is you've changed something. Okay. All right, moving along. Now that we know if it's dependent, independent, or dependent, we then have to find the probabilities when it's dependent or independent. All right, looking at our example 1 then, there is 1 yellow marble, 2 green marbles, 4 red marbles, and 5 blue marbles in a bag. Once a marble is drawn, it is replaced. Find the following, find the probability of each outcome, right? So each of these things. So the big thing here is once it's drawn, it is replaced. Okay, so since it's being replaced, it's resetting it, so that is independent. So I'm going to draw a blue marble, then a red marble. Then is just like the word and. Okay, so that means I'm going to multiply. So I'm going to do the probability of blue. And tells me to multiply. And then the probability of red. When I draw my blue marble, right, there's 1 yellow, 2 green, 4 red, and 5 blue. So let's get our total. There's 1 yellow, plus 2 green, plus 4 red, plus 5 blue. And that equals 12 total. So the probability of blue is there are 5 blue out of 12 times, and then there are 4 red out of 12. When I multiply these together, I get 5 out of 36. Again, I'm just kind of typing it in. I'd just be typing it in my calculator. I'm just kind of doing it quicker. Right? But if I type in 5 divided by 12 times 4 divided by 12, we get 5 out of 36. Okay? The reason these numbers are the same, right, they both have 12, is because it got replaced. Okay? So I took out a marble and I put it right back in. I still have 12 marbles in my bag. Okay? Same thing here. There's 2 green marbles in a row. This means I'm doing green and green. Right? It means the same thing. So I'm going to pull out 1 green marble, put it back, and then pull out another green marble. That'd be 2 green marbles in a row. So really what I'm doing is the probability of green the probability of green. Well, there are 2 green marbles. So that's 2 out of 12. Right, I take out the green marble, I put it back. I go to choose another green marble. I have 2 options that I want to choose out of 12 total options. When I multiply these together, 2 out of 12 times 2 out of 12, using my calculator, I do get 1 out of 36. Same thing for here, a yellow and then a blue. That is the same thing of the probability of yellow times the probability of blue. The probability of yellow, there is 1 yellow marble. There are 5 blue marbles. Okay. When I multiply that together, I actually get 5 out of 144. So, if I'm replacing, it's just like what we did in 5A.2. Alright, now we just have our example 2 to look at. There is 1 yellow marble, 2 green marbles, 4 red marbles, and 5 blue marbles in a bag. Once a marble is drawn, it is not replaced. Find the probability of each outcome. Okay. So the only thing that has changed about this problem is now I'm not putting my marble back. Sorry. Okay, so the only thing different is that this is not replaced. Okay, and so since it's not replaced, that means it's dependent. So we're going to see how this affects how we do our probability. At the first one, we have the probability of a red and then a blue marble. Okay? So I still have my total of 1 yellow, plus 2 green, plus 4 red, plus 5 blue. We still have 12 total. Okay. I'm going to take a red marble out of the bag. So I have 4 red marbles. Okay. So that's 4 out of 12. Let me write the probability of red. Times the probability of blue. And our probability of red again is 4 out of 12. Okay. Well, now again, I'm not replacing it. I took this marble and I kept it. So now I have 1 yellow marble. I have 2 green marbles. I kept my red marble. There's now only 3 red marbles, and there's 5 blue marbles. There's now 11 total marbles. Okay. So we're going to do 4 out of 12 times for our blue, right? There's 5 blue marbles out of 11 total. Well, 4 out of 12 times 5 out of 11 is 5 out of 33. Is a different probability. Okay. So that's the difference. Again, it's not replaced. So because it's not replaced, this number changes. Okay. Looking at part B, 2 blue marbles in a row. Remember, that's the same as saying blue and blue. So I'm going to do the probability of blue times the probability of blue. Well, again, our first total is 1 plus 2 plus 4 plus 5, right? Still 12 total. And the blue is coming from here, right? There's 5 out of 12 that are blue. Now I have my 1 yellow, my 2 green, my 4 red. I took a blue marble. I now only have 4 blue marbles, right? To equal 11 total. So when I go to multiply, I have 4 blue out of 11 total. In this one, right, this went down too. Our total changes, but the number of blue changed because that 5th blue marble is in my hand. It's no longer in the back. This is also 5 out of 33. Same answer. That's fun. All right, last question. A green, oh, nope, just kidding. 2 more questions. A green, then a red marble. Right? I have 1, 2, 4, 5. So we still have 12 total. Right? Okay, so how many of those are green? I don't know what green is. We have 2 green marbles. So this is the probability of green times the probability of red. Well, 2 of them are green, so that's 2 out of 12. Now, since I've taken that marble, I have 1, I believe that's 1 yellow. Now, I've changed this. I've taken a green. There's only 1 green. Does not equal 12 total, equals 11 total. Okay. So now I'm choosing a red, and there's 4 red out of my 11 total. And that equals, I believe it's 2 out of 33. Yes. Okay, so again, I'm typing that into a calculator, or you can type it into a calculator if you would like. All right, last question. You get a blue and then 2 greens in a row. This is the same as saying blue and green and green. Okay. So I'm going to be doing the probability of blue times the probability of green times the probability of green. Okay, so to choose my first one, how many total do I have, right? Move this way. We have 1 yellow, 2 green, 4 red, 5 blue for our 12 total. Nice and easy. So when I'm choosing that blue first, there are 5 blue out of 12 total. So that's 5 out of 12 times Now when I go to choose my next one, right, I have 1 plus 2 plus 4 red. I took a blue. I no longer have that blue. This changes to 4. And that's how we get that 11 total. So now when I go to choose a green, I have 2 green out of my 11 total. Now I'm doing my next green. Well, I still have 1 yellow. I took a green. I now only have 1 green plus 4, and then still the 4 blue. I didn't gain more blue. So now how many marbles do I have? Now I have 10 total. So my total dropped again. So if you do 3 things, it's just going to keep dropping each time. So now I have 1 green out of 10 total. And now I'm just going to multiply all 3 of these things together. You can easily multiply all 3 of them in your calculator. I believe it's 1 out of 132, but I'm going to check because that's a lot of multiplication in my head. 5 divided by 12 times 2 out of 11 times 1 out of 10. Yes, 1 out of 132. Okay. So with the not replaced, right, so these are your key words, right, the not replaced or the replaced. Okay, are you putting it back, changing your total, or not? All right, that is it.